Thanks for giving me the opportunity to speak today. As Chloe's introduced myself, I'm from the Spatial Information CRC. There's a ton of CRCs out there. Ours is all focused around spatial analysis techniques and the questions around data. Hopefully I'll be able to maybe add some more into some of those questions today. I've been with the CRC now for 3 years. Previous to that I was out at Landgate managing a lot of their systems. And prior to that, I've had stints in the private sector looking at remote sensing techniques, using a lot of satellite and airborne data. So, you know, looking at the shape of the land, the use of the land, got a bit of a history there. For those that aren't aware of the CRC, if I can maybe walk closer. CRC, for spatial information, we've got 4 main areas of research, which is the outer diagram here. We do a lot around positioning technologies and systems, analytics, spatial infrastructures, i.e. how do we bring the information together, and geodesy, which deals with the way that Australia is constantly moving. We have 4 applied areas, and we're starting to expand them out at the moment, but what I'll try and focus on is our applied applied research area into agricultural and natural resource management. I wanted to start with this quote. I've been doing a lot of work in the mining sector as of late, and this is a quote from Deloitte, and it's specifically to do with the mining industry, but I think it's quite an important quote because it deals with a lot of sectors. I think there's a lot of similarities, whether you're looking at agriculture, you're looking at land planning, you're looking at automation technologies, you're looking at intelligence transport. But really what it comes down to is, and you guys can read this, the ability to organise, manage and process and utilise that data. It can become quite a differentiator. I.e., if I'm smarter about how I use my information, I can get a competitive advantage not yet available to anyone else. So those questions around how do we share data, what value is that going to provide me? That's a really good point to start, to understand that if I'm going to start sharing my data, how is that information going to be provided back to me? And how do I then utilise it? So organise, manage, process. When we talk spatial technologies, there's a stack of different technologies that have a spatial connotation to it. For me, it's really, if you're dealing with anything that is removing information, removing the land, adding to the land, changing the land, whatever those activities are can be related back to a location. So even if you're driving along, obviously a lot of us probably have GPS systems in the car, that's tracking information. Now spatial technology and spatial analysis really comes to the fore when we say, well, this activity, what influence does it have on the land? What influence does another activity have with that activity? And how can we measure, analyse it and learn from that? And that's a lot of what we do in the CRC for spatial information. So what I'm going to try and cover off is a little bit of our land-related research here. I'm going to go into a little bit of our positioning research, and then some of our spatial tools. Then I'll finish off with what we're doing around data, to give you a bit of a flavour for the next 25 minutes or so. So we've got a very detailed research program around positioning technologies. Positioning technologies that are primarily space-based, i.e. Looking at GPS and GPS-style systems, but then understanding you know, the crustal motion and deformation that happens within Australia, and what does that do in terms of giving us a high accurate position? Being that, you know, how far above the sea level, if I'm taking my positional information from space, how correct is it? Am I correct within 10 metres, 5 metres, 2 centimetres? And we're doing a lot of research around that. So, we're all familiar with GPS, I'm assuming. Who's not? Anyone? Okay, good. GPS, you know, you walk out there in the field, you're going to get a good high level, I would say medium level accuracy. You can walk out there with a GPS unit, stand in the field out there, and you'll get a location. You stand there for a bit longer, that location is going to get more refined, you're going to get a higher accuracy. And that's available to us, and that's been available to us for a very, very long time. What's really interesting about where Australia is located is that we not only see GPS, we see 5 other positioning constellations. No other place in the world really, apart from where we are geographically located, America doesn't see all the other positioning constellations that are available to us. So we not only see GPS, we see GLONASS, which is the Russian system. We see Galileo, we see QZSS, which is the Japanese, we see Beta, which is the Chinese, and IRSS being the Indian. So we're very, very well located to say, well, how do we take advantage of all these different positioning technologies? At the moment, working through Geoscience Australia and Ozscope, we're looking at how all these mixed modal systems, how all these different signals from these different satellites and all their biases can provide you with a higher accurate position when you're out in the field. At the moment, we can take correctional control from base stations spread throughout Australia. That goes to Geoscience Australia. And if you're in mobile coverage range, you can utilise that information to give you a high accurate where you are. And that's probably what a lot of systems use these days. What we're moving towards, and we're doing some trials with regards to SBAS, which is Satellite-Based Augmentation System, is looking at how these correctional controls can be fed to you out in the field, no matter where you are, even if you don't have mobile coverage. Being that you can have autonomous tractors out there that have high level of accuracy without ground control or ground infrastructure being in place. And that's what we're trialling at the moment. I know there are some trials here. Kelly, you're doing one at the moment. We've got a few others in the mining sector as well. And we've got about 27 projects spread throughout the country as it stands at the moment. So what that means is you'll get better than 10 centimetre accuracy nationally without needing to be in mobile range. And that potentially can be a game changer. We've done some of these trials up in the sugarcane industry in Queensland and in some remote farms within New South Wales. And what we did was we did some trials around complete autonomous, no ground-based infrastructure, command and control in some tractors, primarily only using the Japanese satellites. And if this video works, let's see if we can play. No, it's all going to be okay. Rather than trying to play with it. But basically, the tractor itself, no driver, it's fully augmented with a bit of kit and technology connecting to the Japanese satellites, and full, precise, accurate command and control lines being driven by that tractor with an average of only about 5 centimetre error rate there. No, don't worry, that's all cool. If anyone's interested in seeing that video, I can send around the link to YouTube, because that's where we've loaded it. So that's some of the research that we're doing and starting to apply in terms of positional control. So you can imagine when you're out there, if you want good accuracy of where all your equipment may be, if you're looking at tagging livestock, for example, in the future, you'll be able to get very high accurate control of where all your assets and livestock and all the other bits and pieces may be out in the field. For the agricultural sector, like I said, we're doing some trials there, but we're doing trials in a range of different sectors with regards to that research. Now, with regards to spatial tools, agriculture and NRM, so there's 3 projects here that I just want to cover off in terms of what we're doing as research projects. Some of these have come to an end now, and are continually being looked at in terms of what new research projects can stem from these ones are. But the 3 that I'm going to talk about is looking at biomass business, so real-time biomass estimation through satellite-based technologies, but using in-field sensors to provide some ground truthing there. Big data for environmental monitoring. Simon, you've already mentioned big data. It is a great buzzword. When we talk about big data for environmental monitoring, we're talking about the stack and the volume of satellite information and how we can better utilise that to provide real-time information for when we're out in the field. And some work that we're doing in the livestock sector around the red meat area. So, this project, biomass estimation, this has gone through a couple of rounds of research for us. And really it was about the ability to predict biomass and look at paddock carrying capacity through the use of both crowdsourcing information from those out in the field, calibrating that against what Earth observational data we can get from satellite, and then giving you some automated reporting to say, well, this is the current paddock carrying capacity that is potentially available for your paddocks. So what it looks like in terms of the crowdsourcing element to it is we ran a number of trial sites with farmers out in the field. They're taking through a handheld sensor estimations of biomass, so the growth rate within their paddocks, that's being automatically fed into an app so that we could provide the information, and it wasn't there just held there in an Excel spreadsheet or a database somewhere else. It's provided on an app so they could start generating and looking at graphing this information as it comes through and give them a real-time estimate of what they're seeing out in their field. We then calibrated a lot of that back to what we got from Earth observational data, so some of the freely available data sets coming out of Geoscience Australia, such as Landsat, the Sentinel data, which gives you about 10 to 20 metre accuracy, pixel resolution there, to provide that into the app as well to say, okay, well, this is the current biomass feed estimate, biomass paddock carrying capacity in this space. The trial sites that we ran this with found it quite useful, being that the information that would normally be held in different silos was coming together in an app that they could understand and they provided feedback into. So it's an app that gave them the outputs that they required right there and then, but backed by all this information that would have been just held in silos or just not normally made available to them. And we found that has generated quite a lot of interest in terms of, well, how can we calibrate this tool itself for different parts of Australia? Obviously different parts have different vegetation types, different growth rates, different input factors that might affect those growth rates. So just some information about how we're starting to use technology, but provide it to the farmers as they need it, when they need it. This is some of the app features there where we're overlaying ground control and the crowdsourcing of information with the information that's being generated through satellite there. Another project that I want to just talk about briefly is this notion, and I think it comes to the fore around sharing of data. We ran a program of work for about 3 to 4 years called the NRM Spatial Hub. And this was a collaboration with all these groups there, all those logos that you see there. But at its height, we had about 800 farms feeding in information into this. Being that they could either choose to share their data with their neighbours or just hold it for themselves. But the tools itself would then leverage average estimates across the entire region so that a person or a farmer could see the information that they're loading into the system, and we're providing the spatial tools and reporting that would normally not be available to them. They would need to learn the tools, learn the systems themselves, but provide it in such a way that it became basically an automated report for them, and allow them to start collaborating with their neighbours in terms of better land management practices. This is now being generated as a company. The research has come to an end now. It's been generated as a company called FarmMap 4D. I'm not here to talk about them, I just want to really talk about the research that we did here. So the NRM Spatial Hub really started to look at, well, what were some of the difficulties in farmers and pastoralists getting access to information, and how could we really support them getting better access to information, but primarily then to provide that information in such a way that they can start making use out of it. So we looked at web-based systems to leverage the National Archive of satellite data, as well as the processing capability available through federal government to not just provide the data, but process it in such a way that said, well, here is the current ground cover, here is the seasonal average, or here is the time series of the last 20 years of data, here's the average for the area. So that you can look at how your paddock is comparing to the seasonal average. Are you getting worse results, better the results, and what are the weather patterns, what is the seasonal averages, what does that look like over a 10 or 20 year time span, to give you better management tools and practices for your land. So we're able to generate, provide systems where they can load their own paddock, their paddock infrastructure into it, fractional ground cover analysis broken down into their paddocks, seasonal benchmarking, and also then benchmarking paddocks and wider swaths of land over time as well. So the good thing here is the NRM Spatial Hub started to leverage the National Archive, which is actually about 30 years worth of data. Not normally made available to individuals. Organisations, if they wanted to access that information, would have to put a lot of effort and a lot of investment into it themselves. But through the collaboration, through the research project, we're able to start looking at how do we leverage that National Archive to provide it as a useful, meaningful tool for those that are out in the field there. And then how do we validate, how do we ground truth what we were processing? So the biomass tool came into it, other projects have come into it to say, the reports that we generate through the NRM Spatial Hub, how trustworthy are they? How could you use them? And then, looking at then individual needs through the NRM Hub in terms of what, this one feeds into New South Wales government to say, okay, what's the average, what's the reporting that they need to in order to work with farmers, work with pastoralists to better manage their land. So, once again, it's an example of some collaboration coming together to say, how do we use technology in a new way to provide us on-ground tools? The last project area that I want to quickly talk about is what we're doing in the red meat industry. So, once again, another big collaboration, a lot of data sharing happening in this project as well. And it's all about all about managing information within the livestock area, to look at livestock as a value chain, not only from the producer, but also through to the market. And how do we quantify the value at each step of that process, and how do we use spatial information to help support that? So some of the things that we did here was we worked through Meat and Livestock Australia to develop a spatial innovation program. It's called ALSIP. And the aim, as you can see there, was to increase the volume of meat products, but also the grading, the compliance, the value, and effectively come down to livestock producers to say, well, how do we increase, or how do we measure the value, and how do we ensure quality so that you can get a higher grading when you take your livestock to market? And we started to look at all the input and output factors along the value chain, and all the data points were, to say, how do we better understand those data points to both feed upstream what you're producing, but also feed it back downstream to say, okay, well, what did the market expect, and how do you feed that back into what you're producing? This was all focused on problem areas, so it wasn't research for the sake of research. We worked with a lot of livestock producers to say, okay, well, what are the problems that they're seeing in their area? So the scale and diversity of grazing systems, the different technologies that are starting to come to the fore there, how do they start using it, how do they start benefiting from that? Access to historical data, social license to operate, and determining sustainable carrying capacity. These are the problem areas that came to us and saying, well, how do we better utilise spatial information? How do we better utilise the technology in this space? So a couple of points here, value chain feedback. And this is where you really get to the fore of data sharing. So how do you get information back from the processor to the producer to then look at, well, how well your cuts of meat, how they were processed, and what grading quality did you get from that? From the producer to the processor, estimating future turnoff, quality, volumes that you're expecting from us, from the producer, and then the retailer to the processor. What are the expected market demands? So the ecosystem of information, and how do you start better utilising that information to provide it both backwards and upstream as well? And consumer branding was another focus area here. So how do you recognise and how do we generate market demand for the livestock, for the meat that's being produced here? And how do you brand your meat as being sustainable, ethical, having a low impact on the land, and looking at that traceability through the value chain to potentially provide a brand differentiator for livestock. So we're looking at that as well. So we're talking about all these projects, we're using a lot of information, we're using a lot of data, but there's a few key points here that when you're starting to look at the data, whether it's coming from your partners, your collaborators, suppliers, producers, the technology itself, or if you're starting to look at making the investment into the technology, how do you better understand what your expectations are from the technology, from your partners, and what you're going to be able to do with that data? So we look at 6 points of quality, whether it's through technology or data sharing, to say, how do we measure the impact of that data and what is that data going to provide for us? So these measures of quality, I suppose conformity here is probably the biggest one. And this really comes down to, is the data fit for purpose? Have I got a problem? Is this technology going to provide me a solution? And is that data going to provide me additional input or knowledge about what my problem is and how it's going to be solved? So make the data work for you to digital investment. When we look at data and look at the technology, whether it's for our projects or working with our partners, we also have to recognise, and I think Simon, you had a really good diagram there about the continual flow of information. The way we see it across the supply chain or a value chain is that information is not a linear process. It goes both upstream and downstream. So information that is generated upstream can inform downstream, and information generated downstream can certainly form upstream. So in typical manufacturing process, it's a very linear process. When we're talking about data and we're talking about digital technology, the technology and the data that is derived from that technology can it be used many times over, has the potential to be used many times over. So it cannot be simply mapped to say, well, I've generated it here, I'm going to add value as the next step, and then add value as the next step. When you generate the data here, it can inform back downstream as well. So it has multiple purposes there. And this supply of information and its influence on technology is something that the CRCSI is looking very heavily into at the moment. So some of the future research that we're looking into that has a very technology focus, has a very strong data focus, and where the spatial elements are, is looking at this connected supply chain. And it's probably the point that you made, Simon, around midstream. How do we take information and how do we best make use of it for its particular purpose? So we're really looking at connected supply chains, and some of the aims of looking at connected supply chains is looking at then the sensors and the technology that are coming to the fore. How do we generate information from that? How do we then improve the supply chain to really get it down to the value points? And some of the outputs that we want to focus through the use of better use of data and technology is really around improving decisions. How do we use the information to work for us better? And I'll leave it there because I realise I think my time's up here. Hopefully that's given you a bit of an overview of the research that we're doing in this space and the role of data and technology in it,